Welcome to session 8 in the series Foundations of Computer Networks, and in this session we want to have a look at network protocols and network ports. First of all though, let's take a look back at something that we have covered before, which is the client-server architecture. And this is going to be very important, as it will kind of illustrate what happens as data traverses the network. So what we have here is we have clients and we have a server, and we are saying that somehow the clients are able to interact with the server and obtain some sort of resource from the server. Now, the term server typically refers to a machine that has advanced capabilities in terms of storage, in terms of CPU activity, in terms of memory, in terms of RAM, that is. So that is a server, but that is the server from the physical standpoint. What really allows that box to be a server is that it has some software on it that provides some sort of intelligence. So on this physical box, we could install a database server, for example. And what this means is that we can make database requests and obtain information or resources from the database. This could be just raw data, as in text-based, or it could also be maybe images that we want to send over or to share. We also have web servers, we have FTP servers, and we also have mail servers. Example, whenever you load up your email client, for example Outlook, and you want to have a look at your emails, then those emails are stored remotely on some sort of physical device, and that physical device has some software that is installed that will operate as a mail server. So the key point here is that the server, the concept of a server, is both physical as well as software oriented, because if we don't have on the right software, then it won't be able to be a server. And as we just mentioned, the server operates by providing resources to the client. So the client will make a request for one or more resources, and the server will have a look at that request. It will then look internally to see whether or not it can service that request, and an appropriate response is then going to be generated and sent back to the client. Why is all of this important in terms of understanding how the client-server architecture works? Because typically that client is going to want to make use of some network protocols. And if we have a look here, we are seeing some of the network protocols: DHCP, DNS, SMTP, etc. So this model that we have looked at before, this OSI model, becomes extremely important in terms of understanding what is happening in the background as clients try to interact with servers. While this is important in terms of the diagram, we're going to go to another diagram that might be a little bit more simpler to understand. And in this case, we are using the TCP IP model, but the one that uses a 5-layer approach. And it's very easy to understand. If we start from layer 1, notice that the layers from 1 to 4 are exactly the same. We have the physical layer, the data link layer, the network layer, and we have the transport layer. At the top though, we have one layer called the application layer, and if we compare that to the OSI model, it means that we are combining the application phase, the presentation phase, and the session phase into this one thing here called the application layer in the TCP IP 5-layer model. So this sort of simplifies things, because it means that right here at the application layer, where we are just concerned with data, notice that it's just the raw data we're looking at. Then we look at the network services which are applicable for the data to be transmitted. We also look at the presentation information that is done, like encryption and decryption, and translation if that is necessary. And we also look at the session information, where we are going to authenticate who is making use of the services, and also we want to ensure that they have the appropriate authorization, so they are not able to do things that they are not authorized to do. So we will use this TCP/IP 5-layer model as the sort of prism that we are going to use to view what is happening as data traverses the network. Now there is this thing that you need to understand, the difference between TCP and UDP. And TCP means Transmission Control Protocol, and UDP stands for User Datagram Protocol. And the key thing here is to understand the kind of information which are sent across the network as the data traverses. Now let's backtrack quickly. If we want to send data, let's say we have the picture of a cat and we want to send this picture across the network, then what typically happens is that this picture is going to be chopped up into chunks. And then these discrete chunks are then going to be sent over the network. They will find a route over the network, and then they will reach the client machine. So whether or not we use TCP as the protocol or we use UDP as the protocol will determine the kind of information that is necessary for the chunks to be sent properly. If we look at the UDP information, note that we need a source port and we need a destination port. We also need a checksum and we need length. And this is the data that is being transmitted. So this is the payload. But for this payload to be sent, the two important things here are the source port and the destination port. Which leads us to ask the question, what is a port? Now you would have come across the concept of a port before, and in that concept we looked at a port as being something that was physical. So on the switch there is this port, this slot that we plug the RJ45 cable into. But we are not talking about a physical port at this stage. At this stage we are talking about a virtual port. It's something that is logical, that represents what is happening as the data is being transferred. So this concept of a source port and a destination port becomes important at the transport layer. And that's one type of protocol, the UDP. Note here that it says that the UDP protocol is connectionless. And what that means is that we send the data, but it's not guaranteed to reach. And when we say we send the data, it means we're sending the entire chunk that has this packaging on top of it, including the source port and the destination port. So we are going to send this chunk, but there is no guarantee that the chunk is going to be delivered. And if it is not delivered, there is no mechanism that is built in to say resend that chunk. So what it means is that it's unreliable, but it's very fast because there's no additional checks which are being done. If we contrast the UDP protocol with the TCP protocol, however, you will now realize that in addition to the source port and the destination port, there are some other pieces of information which are important, such as the sequence number. So going back to the cat example, the image of the cat, we are going to chop it up into chunks, send these chunks over the network. Now, if it is that it is important to know the relationship between the chunks, then what we need to do is to label these chunks. And we are going to label them by giving them a sequence number. And the purpose of the sequence number is that it will allow us to know, or allow the client to know, how it is to organize these chunks when received. Because bear this in mind, as the chunks navigate over the network, they might reach the client in a different order than which they were sent. And what is going to be necessary is that we are now able to, or the client is able to, look at the chunks and then order them in the appropriate sequence. So this sequence number becomes important, with the first sequence being 1, the second in the sequence being 2, and so on. So that's another piece of information that TCP has that UDP does not have. Another thing here is an acknowledgement number. And what this speaks to is that the client and the server are going to be in constant dialogue. So the client will need an acknowledgement that the server has received the data, and the server will need an acknowledgement that the client has received the data when they communicate with each other. So that is going to be very important there. So source port, destination port, sequence number, acknowledgement number, these are some key concepts in the TCP protocol which are important for the delivery of the chunks to be done properly. Now please note that the TCP protocol is called a connection-oriented protocol, and this is because we guarantee the delivery of the chunk. So if there is no acknowledgement that the chunk was sent, then what is going to happen is that the chunk is going to be resent. So this acknowledgement number and this sequence number allows us to say that it's a connection-oriented protocol, because we can know which chunk is missing and then we simply resend that chunk. Now there's a useful command that you can use on your Windows device. It's called netstat. And what this netstat function does is it allows us to see the protocols which are being sent and the source and the destinations which are involved in this communication. And at some future date in one of our demonstration labs, we can have a look at that. But just note, we're using netstat, and we are using it with some options N, B, and P, which are going to be important, and I'll talk about that when we look at it in our demo. So we are now going to transition into looking at the various network protocols. And at the heart of these protocols is one of these transport mechanisms. Whether it's going to be TCP, which means that we are guaranteeing the delivery of the packets which are being transmitted, or it's going to be UDP, which means that we are just sending the packets, but we are not guaranteeing that it will reach. And I'm using the term packets here in its generic sense. So let's have a look at our first set of network protocols. And what I've tried to do is to group them into categories which are kind of similar, so that you kind of have a basis of understanding what is happening. So here we have a web browser, which we all use. We're going to go to the web browser and we're typing in a URL. Now note that as a part of the URL, we are using a protocol. In this case, it is the HTTPS protocol. And please note that there is a little padlock here that is closed, which indicates that this is a secure protocol, meaning as the data traverses over the network, it's going to be encrypted, and when it reaches the destination, then it's decrypted, which means that if someone hacks into the traffic as it is in transit, they will not be able to make sense of it because it will be encrypted. It is garbled. So that's HTTPS. Now, going back to the concept of a port number is simply a number that is associated with each of these protocols. And the purpose of this is because we're going to chop up that data into chunks, and because when it goes over to the server, there are many different services that might be running on the server. then we need to know, or we need to tell the server which one of the running applications, which one of the running server applications is supposed to process this particular chunk. So in the case of HTTPS, the port number is 443, meaning any data that is being sent using HTTPS, in addition to the source port and the destination port, when we have a look at the destination port, it's going to be saying 443. So that's a critical thing that you need to understand. So the source port and the destination port are going to be filled in with appropriate values. And in terms of the destination port, the number will indicate which service is supposed to be processing this piece of data. So if it is 443, then it means that it's supposed to be processed by secure HTTP protocol service. Now, if it is not secure, meaning that we want to use this browser and get some information, then it means that we are using HTTP protocol. And this HTTP protocol is not secure, meaning as the data is transmitted, it is transmitted in clear text. So anybody who is able to hijack the traffic in transit will now be able to see the content of the traffic. And that occurs on port 80. Please note also, in terms of the transport protocol, both of these are using TCP as the transportation mechanism, which means that these are guaranteed delivery. Meaning, when we send the packets or the chunks, they are guaranteed to reach the recipient. Another thing that we have here is TLS or SSL. So TLS means transport layer security, and SSL means secure socket layer. And for our intents and purposes, what you need to know is that TLS is the advanced version of SSL. Note it also runs on port 443. Once again, we're talking about the destination port. So it runs on port 443, which means that HTTPS is a combination of both the HTTP protocol as well as the TLS protocol. So that's just a fun fact for you to know. Once again, the transport protocol for that is TCP. Now, looking at the web page here, the browser, we also note that there is a name here, www.freecodecamp.org. So that's what we call a domain name. A domain name is one of these human-friendly names that we use in our browser so that we can go to a particular computer or server. The key thing though is that all devices which are connected on the network need to have an IP address. So while as human beings we like these kind of addresses which are human friendly, these addresses still have to be translated or converted into its numeric equivalent, meaning it has to be converted into an IP address. So the protocol that is responsible for that is called the DNS protocol, or the Domain Name System Protocol. And what it does is, as I mentioned earlier, it takes a human-friendly name like freecodecamp.org and then it converts it into its IP address or numerical equivalent. And for these Windows machines, we can use the command nslookup followed by the domain name, in this case freecodecamp.org, and what it will do is give us the IP address that is associated with that domain name. Once again, we will have a look at this in our demo session so that you can see it being used in a practical sense. Also to note that DNS operates on port 53 and it can use either TCP or the UDP protocol. So we're moving forward to look at another set of network protocols. And these are the protocols which now allow us to make physical connections to our remote servers. So there are a few here. Let's start first of all with RDP, the Remote Desktop Protocol, which is a protocol designed by Microsoft explicitly for their use. And the port that it operates on is 3389, and it can run using TCP or UDP. And the purpose of this protocol is that it allows us to connect to a remote machine, and it gives us the graphical user interface that shows us how the desktop on the remote machine actually looks, and then we can make changes and configurations on that remote device. So for example, when you have people who work at help desks, for example, and they want to be able to isolate something that is happening on your machine, then they can use RDP to log into your machine. You will then give them control of the machine, and then they are able to move around and do things on your machine. For example, just this week, I got a laptop from the university, and I wanted it to have printing capabilities. In other words, I wanted it to be connected to the printer. And when I spoke to the network person, the network administrator, then what they did was they RDP'd into my machine, and then they were able now to install what they needed to install, configure what they needed to configure, and ensure that I'm now set up so that I'm able to now use the printer and print. So that's RDP. Before RDP, however, there's something called Telnet, Teletype Network Protocol, which did something similar, albeit that it used a text-based interface or a command line interface, but it does a similar thing. It allows us to connect to the machine, and once we connect to the machine, then we're able to do stuff. We also have SSH, which is Secure Shell Protocol, which does the same thing as Telnet, only that it now offers a bit more security in terms of encrypting the data as it is being transmitted. So that is SSH, and please note SSH uses port 22, whereas Telnet uses port 23. And I'm just going to say it again so that I can re-emphasize the point. This port number is simply a number that is going to be attached to the chunk, so that when the chunk goes over the network, the server that receives it knows exactly which software it's supposed to send it to for it to be processed. So what else is here? We have the FTP protocol, the file transfer protocol, which is pretty much used to download files and upload files. Alright, so typically you'll have a client interface, like maybe FileZilla, for example, and once you log into it, you authenticate and so on, then you'll now get access to the FTP server that has the files that you need to interact with, and you can upload files from your machine, or you can download files from that FTP server. And the ports which it works on are ports 20 and 21. One of these ports allows it to send data, I think that is port 20, and the other one facilitates control information that will ensure that things are being done smoothly. So that's the FTP protocol. And that runs on TCP. So once again, it means that the chunks or the delivery of the chunks are going to be guaranteed. And if we have a look here at this diagram, I think it helps to illustrate the fact that when the file is being transmitted or downloaded, then it's chopped up into chunks, and these chunks can arrive at the client in different order. So notice these kind of dark green slots indicate that those chunks have been received. And you notice that at some point, there's some breaks in between what has been received. And as things progress, then these missing pieces will be filled in as those appropriate chunks are received. So, just to give you a visual there. Now TFTP, that's Trivial File Transfer Protocol. And this is typically used to transfer small files. So because the file is small, we typically don't need to do all of these exotic checks, because if it was not received, then we can send it again very quickly. And that operates on port 69. Now on to the next set of network protocols, and these have to do with the mail server. So here we have our mail server. So once again, it will have on the appropriate software that allows it to process these email data. So first on the list is SMTP, the Simple Mail Transfer Protocol, and as the name suggests, it is there so that we can transfer or send data from the client over to the mail server. This operates on port 25 and the transport mechanism is TCP. Now on the receiving end, on the mail server, there are two protocols which are typically used. One called POP, and it's really POP version 3. So that's Post Office Protocol, which runs on port 110. And then there is IMAP, which is the newer standard, the Internet Message Access Protocol, and that runs on port 143. And please note that these are both TCP protocols because we want to ensure that all the chunks are delivered. Just to quickly mention something about POP though, why IMAP is the recommended way. And if you are using POP, then once you go to once you log into the mail server and you download those files from the server, then what it means is that it removes them physically from the mail server and you now have them stored locally. The challenge with this is that if you now log on to a mobile device somewhere else and you connect to that mail server, then it means that all of those files, all of those emails would no longer be physically stored on the mail server. And as such, it means that you can't get access to them. And this is one of the reasons why IMAP is being used, because it facilitates us leaving the email data on the server so that we can connect to it from a multiplicity of devices and still get access to all of the information that we need. And to wrap things up, we are now looking at the DHCP protocol, which is the Dynamic Host Configuration Protocol, and this runs on port 67 and port 68. And please note that the transport protocol in this case is UDP. So what does DHCP bring to the table? The purpose of a DHCP server is that it's going to automatically give out valid IP addresses to each client that connect to the network. And you see this in operation as you navigate through these different organizations and you connect to their wireless router, or you connect wirelessly to their network. Remember, for communication to take place on a network, then it means that each device needs to have an IP address. And that IP address needs to sit on the LAN. We have looked at this before in terms of all our demonstrations so far. So the IP address has to be consistent with the LAN on which this client is going to be connected to. So instead of having a human being sit down and manually assign these addresses each time, we can set up a range of IP addresses on a DHCP server, and as clients connect, then they are automatically issued with an IP address. Now, while I say an IP address, that's the primary thing, but you'll also get some additional stuff. For example, you'll also get the subnet mask as well, because that is important in terms of determining which network this IP address is associated with. And another thing that you'll also receive is the default gateway. And remember, the default gateway is important because that defines the entry point and the exit point into and out of the network. So this is critical, especially if you're on the network and you want to be interacting with devices on the internet, for example. And that takes us to the end of this particular session, where we have looked at network protocols. And bear in mind that we said network protocols, so we are talking about these protocols which are found at the application layer. When we're talking about our 5-layer, let me just quickly go back to it. When we're talking about our 5-layer model, TCP/IP model, we're talking about all of those protocols which exist at this application layer. And we have a couple of them here, and I think we have done all of these and even a little bit more. But suffice it to say that there are other protocols which are also observed, but not at this level. For example, we have looked at ARP, the Address Resolution Protocol, that converts an IP address into its MAC address, and that is actually located at layer 3, or at the network layer. So thanks for listening. Please remember to like and subscribe and to share, and I'll see you in the next one.